Morning, folks. Good morning. Just finishing my egg. There we go. Last bit. One more second, please. Let me get the background ready. Whoopee. Here you go, folks. We are in. Looking good. Looking good. Looking good. Just want to make sure that NVIDIA broadcast has this bright microphone this time. Speaker we don't care too much about. Microphone is the right one. I'm very surprised you people have reported not feeling a difference between this microphone and because the webcam was on for a long time. You missed it. I hacked my notes for hours straight. Nice. Nice. I hacked my notes. So you hacked your notes? I remember you were transferring your notes, making a lot of notes for Bandit. You were hacking on stream? I put some music already. I'm still on Hack the Box Academy and doing all that. So all that note-taking fundamental study stream. Nice. Too bad I didn't get it recommended on my stream. I just went in on Twitch almost an hour ago. Browsed and I didn't see you being recommended. That's too bad. I didn't think about going. Are you in InfoSec streams? Oh no. Oh, okay. This was a cutoff. Oh, but you were on, no? Is XR in here? I'm not on there yet. That's the goal, to be fair. Nice. It takes a little bit of time, and once you're there, it's good. I should definitely insert my YouTube eventually. Whoa. Blues boots. I should definitely insert my YouTube on Hacker and Capad. Okay. Nice. Okay. Cool. You got able to do some of your notes. So Hack the Box Academy, do all of that. Nice. Super cool. It's nice to be able to get some good notes and be able to share with folks. It's important. All right, let's play this. I want to play this. Play this. The fuck? Spotify. No, so you can hear it. Cool, folks. Cool. Let me get the Cyber Doctor outfit. Let's get Oracle box in. Please pardon the screen flash. It won't last long. Yesterday we were looking at some sort of hacker. My eyes are burning. Let me turn that off for you. I don't know. It says powering VM. There they go.
Here's the thing.
Oh.
You have to.
Was he still online? Or that was yesterday? I think that was yesterday. So yeah, we're the only ones so far on InfoSec streams. bit. So yesterday, XR, we're doing. Wow, we went far, huh? While you were gone, we went a bit far. So we just gonna recap a bit yesterday. We started doing a challenge for binary exploit, and to be honest, we still don't understand what it is, what it consists of. So we decided to go learn about it. We went on Pawn College. And then when we got tired of that, we went to looking for books that explained cybersecurity well. This is how they tell me the world ends. So we were looking for, I want a simple book on a specific topic. The Anderson book is far too large and derived from the core topics of cyber economics. So I thought recently about the idea of cyber economics, how books on binary exploitation would be an art of the exploitation. Yeah? Wow, I don't know if I want a book on binary exploitation. You've read this one? How did you like it? I'll search on my phone. Art of exploitation. Yeah, I think it's important to put hacking at the beginning. 2003. About computer security and network security. It was published in a No Starch Press in 2003. With second edition in 2008. They were tested on G2 Linux. I have this one. I would not state that I have read it in its entirety, lol. Yeah, it's a wow, 2008. I'm not sure how relevant it is today. But hey, you read it. You didn't read it in its entirety. You read it a little bit though. So what did you think? Folks, my computer mouse stayed in my bag. I'll be right back to get it, and I'll put on the lab coat. Be right back. I think this jacket is just a little bit colder than the other one. There's a massive stain. Wow, there's egg on my pants. What the fuck? How did I put egg on my pants? The fuck? I don't think that's you expect your streamer to say. I have eggs on my pants. Okay, whatever. Alright, books on binary exploitation would be art exploitation. I have that one. I would not say entirely. I have a book on BSD. So, relevance is up to the user. BSD. What is BSD? BSD hacking. Hakong. Administración avanzada de personalización de sistemas BSD. Ooh, BSD hacks industrial tips, so it has a kind of industrial. BSD hacks 100 industrial strength tips and tools. In the world of Unix operating systems, the various BSD come with a long heritage of quality software and well-designed solutions, making them a favorite OS of a wide range of users. Making budget-minded users who adopt BSD early on onto developers of some of today's largest known sites. Oh my god. Largest inside the popular BSD system continues to grow. If you use a BSD operating system, then that's the secret of success. Not just a sprite tag, it's practical. It's not that bad. 24 euros. What is it from? 2004. God, XR. There's some of these old books. Unix and Linux System Administration Handbook. I like that cover. What the fuck, though? People should stop making white websites. Handbook, 5th edition. Okay. Looks like they're having fun. Unix comes before Linux. Linux is equal to Linux Unix. Yeah, I heard this before. Noise. So folks, I say we keep going on Pond College. We had a pretty good idea of memory errors introduction. Let's see high-level problems. I think we need to learn how to do this. We can keep going back and forth, but I think we need to learn how binary code hacking works. I'm not sure if I should take notes because I don't remember what we did yesterday. I think it's pretty safe to say I should take notes. So folks, today there's gonna be a bit of video. It's gonna be a bit of a video. We're gonna be watching a few videos on binary exploitation. Hope that's cool with you. And we're gonna take some notes on the side. So let's open a cherry tree until we deal with something for this weekend. Notion or Obsidian? XR recommends Obsidian, so we'll go for that most likely. All right, and here we want to do binary exploitation. So yeah, folks, we're gonna look at some videos from this machine. Hopefully it works well. And after we'll be able to hack a bit more into the bits. So let's go. Let's look at this video. We saw memory errors introduction, memory errors, high-level problems. Let's do it. Bedro, cyber doctor performs cyber surgery. Patient has their cyber penis caught in the M&M's jar. That's a tough case. Perverse cyber surgery. Patient has a cyber penis caught in a jar of M&M's. Oh my god! You have to pull it out through vulnerability. You have to see if the M&M's bar has any vulnerabilities to safely remove the penis. Well, I mean, the thing about the cyber penis is that you can always buy another one and just put it on for you. Bro, why do you derail? No, Bedro. I will not accept that I was the one derailing. Bedro trying to gaslight me. Okay, cool. No. It was on you, Bedro. It's a completely legitimate sentence. Yeah, and so is my answer. Nice, Bedro. Thank you for coming with this scenario. I would just get the patient another penis, and I would keep the jar of M&Ms for another patient, right? Another patient only. I'm needed to sleep. Maybe. I don't know. You're the one that decides, Bedro. Yeez. We're doing binary hacking if you want to join us.
Video 2 of the memory errors module of Pwn College.
Taught by a real nerd.
Today we're going to be talking about high-level problems that lead to memory errors. As a reminder, in the previous video, I talked about how Dennis Ritchie, this man on the right of the slide here, created the C programming language. He created it to create utilities for the Unix operating system, which he had co-created just several years earlier. C was designed to give low-level control and power to the developer to allow them to write fast code but still use a source code, a high-level language to write it rather than writing it directly in assembly. Um, in Unfortunately, in combination in a way with the von Neumann architecture brought to us by the three Johns, these figures on the left, um, and von Neumann's architecture's um, kind of seeming thoughtlessness
Wish you didn't
about
have to stream at Eastern European times. Yep, I wish so too. Anyway, have a fun stream. Thank you. Yeah. I mean, it's Western Europe, but yeah, it kind of is Eastern Europe time. That's the time I have for now. But yeah, thank you for coming on, Bedro. Have a good night, good evening. Today, yeah, we're gonna be focusing on learning, folks. Just watching videos. Thank you. Ciao, Bedro. Yeah, sure. I do stream a bit late. It's how it is, you know. Maybe I'll switch at some time. But for me, it's super nice because it's super regular. I wake up like, coming back from work. I'm probably gonna have 26 things to do. But the thing is, I don't really have a plan, and neither do folks at midnight have a plan. It's kind of easy for me to keep it regular, right? I don't think there's a lot of streamers that are every day or every work day. So if I have to choose something that works, it's probably something that allows me to stay up at the same time every day. And the only time I can really do that is from 6 to 8 a.m. my time. Hey, I get to spend regularly 2 hours with you folks. It's really cool.
Security, the rise and amazing spread of C has led to a state where we are plagued with memory errors in software even now to this day. So let's look at some of the high-level problems of these errors that lead to these errors. The biggest problem, kind of the overall general summary, is that C trusts the developer. In Python, if you create a list with 3 elements in it and you try to access the 11th element, Python will tell you, no, this list only has 3 elements. You're not accessing the 11th.
The issue with C is that it trusts the developer. I kind of want to understand what happened here. Do you see how it just gave out 0x41? Is that the bit,
Absolutely
the byte?
no way. It'll throw an exception, and then you will realize, oh, I'm accessing an element that I shouldn't be accessing, and you can fix your code. C won't do that. In fact, C cannot do that. C is designed, again, to be as low level, as direct translation as possible. All C really does is take the burden of register management away from you, and handle, calling functions and so forth in a nicer way than assembly might. And let you create structures and et cetera, et cetera. Of course, C does a lot, but what C doesn't do is implicitly track things like the number of elements in an array. If you want to track the number of elements in an array and be very careful to check if the array is big enough before you access it, of course, you can write that in C. You can create a structure that has both an array and a size. But realistically, if people do not do that and they just access memory willy-nilly, C will let them do that, and problems will arise. The problems that will arise have to do with some of these other high-level problem causes that I'll talk about. To begin with, C mixes control information and data in the same place. You should remember the stack.
That's interesting though. So programs start up with potential influence data already present. Do you understand these? Text, heap, stack.
Stack. You learned about it and hopefully had to deal with it a lot in the previous module in reverse engineering. The stack holds a lot of user data. I mean, there's user data actually. The stack starts out holding a lot of user data, but user data throughout the execution of program spreads all over the place. Unfortunately, in those same general memory regions, programs store a lot of control information. And they store this together with the non-control data that, including user data that is stored.
I kind of want to understand these two principles. So we have text, heap, stack. A YouTuber is explaining issues in C by illustrating it through three. The guy did say through the previous model of reverse engineering, and we didn't do that. It's kind of like, oh, oopsies. Text, heap, stack. Dot text. Dot text, heap. And what was the third one? Stack. And stack. What are those? In C, most low-level languages, and most low-level languages, a running program's memory is divided into sections. The three your YouTuber mentioned, text, heap, and stack, are the core ones. Think of them like different zones in your program's RAM, each with a specific job. Here's a clear explanation. One, text section, this is where your program's actual compiling instructions live. Machine code of your functions. Compiled instructions from your C source. Key properties. Read-only, fixed size, you won't allocate here. You don't store variables here. Okay. So it stores just kind of functions. Okay. Do you know all this already, XR? There are three core parts of a that live in the machine's RAM on code execution. One dot text. This is where the functions of the code are stored. Two. Okay, let's keep reading. This is where local variables and functions live. Two, this is so stack. Stack is where local variables and functions calls lives. And function calls live. Okay, that's pretty good. We understand that. Automatic memory management, very fast. Stack is like a stack of plates. Add, push, remove, pop. This is what we say Python when you remove something from a list. You say pop. Pop, pop, pop. I've been somewhat introduced. I know C is the language that codes operating system that allowed it to become portable to other hardware, allowing for some abstraction outside of assembly. You use pretty fancy word here. I like that. Been somewhat introduced. I know C is the language that codes operating system, what allows it to become portable to other hardware, allowing for some abstraction outside of assembly. Nice. That's like almost textbook, huh? When you say what allowed it to become portable to other hardware, allowing for some abstraction outside the assembly. Nice. That sounds really professional. um, so cool. You already know a bit about C. Now we're gonna. I'm not sure. Do you know about like the in depth of this, like heap? I have no idea what this means. And lastly is heap. Do you okay? Memory you manually allocate at runtime. Large flexible slice slower than stack. Must run free manually. Memory output. Stack heap data BS S text. Okay, it's very important for C security. Wow. Allocated memory at runtime. I'm not sure what that means. Folks, we're getting deep into computer science here where it's not just malloc when you manually allocate memory and you have to pay attention, otherwise it's a buffer overflow or attacking the stack. You have a pretty good idea of what all this does then. XR, that's really good. Analogy, heaps is like the warehouse. You request space, you must return it manually. Okay. Visual diagram, memory layout. So you have stack, then you have the heap, then you have the dot data, dot BSS, dot text. Why this matter? Very important for C security. Stack overflow, care buffer 10. Gets buffer. Too much input override stack. So car buffer 10 gets buffer. Too much input override stack, crash or exploit. Example, heap overflow. Car star p malloc 10. String copy. This is too long. Okay. Overwrite heap memory. So you make it, you kind of bind this to a certain length. Example, hackers try to redirect execution into malicious code. Simple real-world analogy. Imagine a restaurant. .text is the recipe book. Stack is the chef's working table, and heap is a storage room. Okay. Bonus, there are actually more sections. Complete layout, .text code, .data initialize globals, .bss initialize globals, heap dynamic memory, stack function memory. I don't get that. If you're learning about cybersecurity, this is critical. Understanding this function for buffer overflow for reverse engineer malware analysis. If you want, I can also explain Stack Overflow visually step by step. I think we're good. We're going to get this probably later. Okay. Nice, folks. So, Programs start up with user influence data already present. Users' data should not directly control programming execution. It is normally non-control data. However, it is stored together with control data. Okay.
Together with the non-control data that, including user data that is stored. Recall the stack, for example. Everything on the stack is just jumbled together. Functions have their function frames on the stack containing the return address. Or let's start actually from the left here. The local variables of the active function, some of which are user controlled, potentially attacker controlled. Saved pointers to other places in memory. For example, the saved base pointer for the stack points elsewhere in the stack. Saved pointers to code, pointers that are later used to return from the function. And further to the right in the stack, further up the stack, local variables of the caller function, the function that called that function, the function that called that function, and so on. There's a lot of data on the stack.
Okay, let's look at Stack. Because there's usually... Isn't this... There's a Stack Overflow website, no? This is for debugging, and it's newest questions. Stack Overflow for Teams is now called Stack Internal. They got destroyed by AI, I think. Stack Overflow. I wonder if there's a relationship here. Is there a relationship? Reason Stack Overflow, the platform, is called this way. Not gonna lie, binary exploitation is not a beginner level topic in the world of hacking, just my opinion, lol. Yeah, I mean... Yeah, it's not. So, but we're gonna have to tackle it eventually, right? We're gonna need to tackle it eventually. Why not now? Yeah, it's hard. It's hard stuff. Do you think it makes sense to... XR, I trust you. I trust your judgment. What do you think? Is this too much for now? Named after Stack Overflow errors. Yes, Stack Overflow is named Stack Overflow, which is one of the most famous, frustrating errors programmers encode. What Stack Overflow is, as explained before, the stack stores functions, calls, and local variables. A stack overflow happens when the stack runs out of space, usually because of infinite recursion. Most common example, void function calls itself forever. Okay, it's because you do trash programming too. Each call uses more stack memory, eventually it crashes with Stack Overflow. That is valid as well. I think learning C is somewhat fundamental in understanding binary exploitation, so being familiar with the language being used is in the example. That is valid as well. I think learning C is somewhat fundamental in understanding binary exploitation, so familiarity with the language being used in the example. Oh yeah, it's important. Look, we'll see. I say we keep going until we really hit a wall, and then we can save our progress and save the checkpoint and return later for revenge. I think revenge is good. We're pushing the boundaries a bit, little by little, of what we can do, right? And revenge is all the more sweeter, the more sweeter when we get to it. All right, each call uses more memory stack. The book Hacking the Art of Exploiting AI, Roy. Hey, Stack Overflow has been replaced with Stack, by the way. Yeah? What do you mean? The platform? How can an MC in Dubai adapt their style for different events. That's interesting. How to extract SharePoint list properly using client secret and its value. Votes -1. Someone got angry. Oh, wow. -3. Found the duplicates with button click. I want to list out the duplicates. Closed. Why are people so angry? That's not a lot of questions, huh? In the last hour, we've seen only... Last 2 hours, there's 1, 2, 3, 4, 5, 6. The site has been hacked. It's now stack. Oh, I didn't know. The book Hacking the Art of Exploitation as You Code Languages in C and Decompiling to Understand What is Going On. So you think I should buy that book? The book Hacking the Art of Exploitation has you code languages in C and decompiling to understand what is going on. So yeah, tell me XR, should I get that book? I'm pretty down to read a book at the same time. Foxon 1004. Whoa, it's a lot of points. Code programs, not languages. I have it. We can make it a book club project. I'm down. Ooh, we can make a book club. I like this book club idea. I like it, XR. And then we can wear glasses, drink matcha. We'll make it real. Book club. I didn't hear about this Stack Overflow being hacked. Oh, to our May 2019. Stack Overflow is dead. Here's why. Il colapso. The Stack Overflow. Someone's talking about it. Mid-ULive. It also comes with its own VM that you can go through with its exercises as well, but it requires some setting adjustments to get it to work, lol. I don't know, I think it's a good idea to get some book and maybe get a book club going. Because I don't know when I'll read the book. Alright, let's keep moving, folks. Nostach, com hacking to HTM. Alright, let's see it. nostarch.com/hacking2.html. HTM, there's no L. Okay, never mind. No stash. No starch. Forgot the R. No starch. Doom, doom, doom. We were just talking about it yesterday. Add to cart book and free ebook. $450. Holy shite. I'll see if I can get it on the Art of Exploitation. I think I took a photo of it. Let's see. Where's my phone at? Right there. This we can make a book club, I think. Be really nice. A monthly book club? Wouldn't this be lovely? Like on the first of the month, of every month, first day of every month, we talk about a book. Wouldn't this be fun? Then we could have an exclamation point book club. The VM should be free. About live cyber doctor. The VM should be free about live CD. Okay, let's write it down. I have a lot of books to read. Hacking, second edition. Hacking, the art of exploitation. So if we do one, this book has how many pages? 488 pages. If we do a monthly book club, we have to read about 15 pages per day. 15 pages per day of hacking, the art of exploitation. Hacking APIs, Linux basics for hackers. That's about good. That should be good. The VM should be free about life cyber. The VM. Why would this VM be free? So yeah, we can start a monthly book club. Maybe that'd be fun. That should be doable. No, 500 pages. We talk about a book and our takeaways from the book. Maybe it'd be nice too to eventually bring the author and do a little interview. Wow, it'd be wild. It'd be crazy. Crazy. One thing at a time. One thing at a time. So yeah, maybe we're gonna start this. Maybe I can order it. So many things I can do for the stream. Oh my god, so many things that we can do. Kind of so little time too. All right, let's keep going. Thank you for the recommendation, XR. I think we're gonna use it.
Stored together, and it's all treated exactly the same, which has serious security implications. Earlier,
All right, let's recall. Thus, I just said recall because it was written recall here. Everything is jumbled together. Local variables, the active function, save pointers to other places on the stack, or data in memory. Saved pointers to code, return addresses. Local variables of the color function and its color function and so on. All of this data is stored together and treated the same. So yeah, you can kind of exit where you are. If you say A10, it's gonna go further down the road, I guess.
we talked about accessing the 11th element of a
You say humble bundle. Humble bundle also sets a few ebooks at good price if you can catch those deals low. Never heard of them. Humble bundle. Bundle. Humble bundle. Game bundles, book bundles. Bumble. That's pretty good. It's a cool idea. Great games every month with humble choice for only 13 bucks. We're more looking for books. Woof. Get that light screen away from me. Oh wow. It's nerdy books, so that's good. Crown of the Empire. The Art of Writing Efficient Programs. Learn Python programming. This is something Jim the Dandy would hate. Creating software with modern diagramming techniques. Designing data governance up from the ground up. Oh my god. Really nerdy books. Alright. Cool, folks. So let's remind ourselves, yeah, data can go over different ways. Local variables of the color function, and its color function, and so on. All the data stored together and treated the same. Okay. Kind of makes sense.
Of a 3-element array. Well, of course, what happens when you do that in C, if your local buffer is this A array, you end up accessing somewhere in here and writing data directly there. That's really bad news, right? What can you do with that? You can do a lot with that. You can, for example, take a return address that was pointing somewhere in the .text segment section into the code of the program and change it to point somewhere else, or change it to point to some shellcode that you injected, if you recall the shellcoding module. This is a big problem, and in fact, this problem on one sunny day, probably it was sunny somewhere, in
15 till 1. Time for bed. Enjoy the learning. Thank you, XR. Thank you for all the recommendations. We'll take them into consideration. I'll check it out on the public transport today. I think I'm taking public transport. Ciao, XR. Take care. Better get up. I kind of look like a slop. All right. So disaster strikes. First time there was C. It was C being broken apart.
1988, Robert Teppan Morris used this exact situation, a stack-based buffer overflow, where he overflowed from some buffer on the stack and overwrote the return address. He used this to create the first documented memory corruption exploit, as far as I know.
Accidentally brought down the entire internet. Damn, son. He looks like he's getting arrested. But I think it's pretty cool to be arrested for being the first to do a stack overflow attack, and he knows it. He wore a full-on costume, a full-on suit, the classy kind too, with multiple layers. He's like, I'm gonna get arrested. I'm gonna get arrested right. Nice.
As I know, launched the first designed worm and brought down the entire internet. We talked about this back when we talked about shellcoding, but these are the exact bugs that he used to do all this damage accidentally. The damage was so great that the internet had to be basically shut down, disconnected, fixed, all of the machines, and then plugged back in. Imagine doing that now. It would be insane. For this, of course, I mentioned before, he was convicted under the 1986 Computer Fraud and Abuse Act, but I didn't mention that he has since become a CS professor, computer science professor at MIT, and co-founded Y Combinator and a bunch of other ventures. So he
pretty badass.
Doing quite well, despite his shady past. All right, let's move on to problem 3, right? C mixes control data and non-control data in the same way C mixes data and metadata, right? And this is also problematic. It's very similar, but also problematic. Consider the simplest example is strings. You should all know strings are null terminated in C. When you have a string, you say, the name is Jan. In this case, this 10 character array with initial.
Just take notes real quick from what I understood. I think what I understood is that everything is taken sequentially. Without differentiation between with user input. So that's the one thing about it, right?
The value of Jan holds 10 bytes. Jan and then 7 null bytes. 3 of these bytes are data, Y, A, and N. And the null byte actually is metadata. It encodes, it says, hey, this is the end of the string. This implicitly encodes the size of the string using just a single byte, right? And the size of the string is basically the beginning of the string up to where the null byte is. This is problematic. Consider if you are just inputting a name using the read system call that just gets a bunch of data. And you do something like read from standard input into name, and then there's a macro in C that gives you the size of a variable, say the size of name. This looks reasonable at first glance, but there are some problems. First of all, it allows a user to inject null bytes anywhere they want. Read will happily
Wait,
take
null
them.
bytes. So why is that an issue?
Put a null
with
byte.
Null bytes in there. What if there are no null bytes in the input? I'm not sure.
Byte instead of the A in Yan, and suddenly, instead of a 10 length string, I have inputted a 1 length string and a bunch of other data, the status of which is questionable, right? Because any string operations will terminate on that null byte. Likewise, what if there are no null bytes? This is even worse. If I just fill all 10 variables, all 10 bytes, excuse me, in that variable with data.
Yeah, what's the issue?
How long is that string? C, as a reminder, stores no other length information. It has no way to know that this is, after compiling the code, it has no way to know that this used to be 10 bytes long, right? So further operations on this variable, lacking that null byte that encodes its length, the string's length, might do weird and crazy things.
I have no idea why
Alright.
that is an issue. Let's take it big and ask ChatGPT about this.
Final high-level problem we'll cover.
Can we make it big?
Initialization.
Yep.
And
Let's go back. All right, let's ask for ChatGPT to explain this to us. Can we take a screenshot? Wait, I've never tried here. I don't know if I can take a screenshot here. No. Let me search for it. Screenshot. Nice. Copy clipboard. Okay, okay. Nice. Explain this slide to us and answer the questions. Folks, I'm not sure how comfortable you are with C. Hope you're learning something, because I certainly am, but it's not easy. This slide is explaining a classic C vulnerability concept: strings max, mixed data, and metadata. And that can break when using a low-level input like read. Mixed data and metadata, and that can break when using low-level input like read. Let's go step by step. Part 1, the starting point. Card name 10, Yan. This creates a 10-byte buffer history. Memory looks like this: EYAN 0 and then unknown things. Yan is the actual data. Null is the null terminator. Nice. And so this is the memory we've allocated to it. The rest are unused bytes. Okay, so data is equal to Yan. Metadata is equal to position of 0. Yan, metadata. What is metadata? Do you folks know what metadata is? What is metadata? I think it's like data about the data. Does that make sense? Yeah. Something people say all the time. Providing crucial information, context, description, and structural information for digital or physical resources. It facilitates finding, managing, and using data by detailing aspects like creation, date, author, file type, and permissions. Key types include descriptive, like author, title, and structural, which means administrative, technical rights. Key aspects of metadata. Definition: it is contextual information that describes, explains, or locates data, making it easier to retrieve, use, or manage. Okay. So metadata, it's about the data, right? It tells you like the data finishes. Critical idea: null byte is metadata. Null byte is metadata. In C strings, the null byte marks the end. There are no separate length variables. There is no separate length variable. So C figures out length like this. Read characters until this. That makes sense. The dangerous line. Read 0, name size of name. Read 0, name size of name. This reads 10 raw bytes from input to name. Read does not add a null terminator. It just copies bytes. Question 1. What if there are null bytes in the input? Soshi. But why would there be Soshi in there? Yan Soshi. How C sees it. They see Yan because Yan stops at 0. Everything after is ignored. Program thinks string is Yan, even though more data exists. What if there are no null bytes in the input? An input. So Yan Shoshi becomes Yan Shoshi exclamation point. No null terminator. This is dangerous. Now cease tries. Print F's name equal. Continue reading after the buffer until it finds a null somewhere else. Whoa. Okay. That's kind of frustrating. So why do we code in C then? Answer, C will read beyond buffer. Leak history, simply crash. Why is this slide called mixing data metadata? The null byte is metadata, string length stored inside the data buffer. This is bad design. Modern languages separate them. Example, Python. String stores pointer to data, length separately, so no confusion. Why hackers love this? This is because vulnerability 1 memory leak. Reading past buffer exposes secrets, passwords, keys, pointers. So yeah, maybe as a hacker, you might want to insert, if the space is 10 bits, not bytes, bits, then what you may want to do is Stack Overflow this shit. Sorry about that, folks. Is put too much on it so that you can reveal more data afterwards because it won't find a 0, for instance. Crash, segmentation fault. Vulnerability 3, exploitation, core foundation of buffer overflow, info leak, RCE. Read real vulnerability example. Car buff 10. Read 010 buff 10, print 10 buff. If attacker sends 10 non-null bytes, leak memory. Yeah. Correct safe fix. Always add null manually. Name n is equal to 0. Now safe. Okay. Final summary table contains null. String ends early. No null. Streets reads beyond buffer. Read behavior does not add null. Risk memory leak exploitation. This concept is extremely important in exploitation. It's foundation for stack overflows, heap overflow, information leak. Yeah, why do we talk about stack overflow and never like .text overflow? I'm gonna ask this question to ChatGPT. Why do we talk about stack overflow and heap overflow, but never about .text overflow? Also explain how a heap overflow is different from a stack overflow. The reason you hear stack overflow and heap overflow but almost never text overflow comes down to what lives there and whether it can be overwritten. There is no .text overflow. The .text section is read only. Okay, so we can't really input stuff there. The .text section contains compiled code, and modern operating systems mark it readable, executable, not writable. This protection is called W to the power of X. Write XOR execute. XOR is also encryption algorithm, no? Write XOR execute. If memory is executable, it cannot be written. If memory is writable, it cannot be executed. So you cannot overflow into the text and modify it directly. Overflow happen in writable history, writable memory. Overflow require a writable buffer that can be overfilled. Only these sections qualify. Stack, writable. Heap, writable. Data BSS, writable. Text is not writable. So no writable, no overflow possible. Historically, .text attacks did exist before predictions, 1990s. Attackers could modify the code in memory. Modern protection prevent this. Now attackers do something smarter. They override pointers to redirect execution into existing .text code. This is called return to the libc. Okay, ROP, return to oriented programming. They don't overflow text, they redirect execution to it. Now, stack overflow versus heap overflow. This is very important. Definition of stack overflow is overflowing a buffer located on the stack. Okay. Yeah, it makes sense. This overrides what gets overwritten, and then may expose data. If attackers return address, control execution. Stack overflow is used to hijack control flow directly. This is the classic exploit. Overflowing memory allocated with malloc. Char p malloc is equal to 10. Overflow occurs in heap memory. What gets overwritten? Heap contains other heap objects, heap metadata, pointers. Example. Object A, object B, overflow target. Key difference summary, location, stack heap, location, automatic, return address. Okay, kind of have an idea, kind of don't. Kind of, it's getting a little bit clearer. Let's see. I think it's going to get pretty good, a bit easier with practice.
If I just fill all 10 variables, all 10 bytes, in that variable with data. How long is that string? C, as a reminder, stores no other length information. It has no way to know that this is, after compiling the code, it has no way to know that this used to be 10 bytes long. Right? So further operations on this variable, lacking that null byte that encodes its length, the string's length, might do weird and crazy things. All right, final high-level problem we'll cover, initialization and cleanup, right? Again, C is very low level. Unless you tell it to, it will not do any initialization or mostly any cleanup. All it will do in terms of cleanup, for example, is add to your stack pointer to quote unquote deallocate the stack frame. And I talked about in the previous module how deallocating the stack frame doesn't actually remove any data, right? In the cleanup stage, C just moves the stack pointer. That old data is still there. It's just now to the left of the stack pointer, so it doesn't really conceptually exist in normal program operation. But it's still there. You might still be able to access it if there was a memory error in the program. Likewise, initialization. C won't initialize anything unless you tell it to, unless you explicitly initialize it. If you look at this example, there's a character array called myVariable, and it's of size 8. When when this program launches, when this function is called, what will be the value of myVariable? it won't be nulls. In the previous example, I had this initial value. This is an initialization that explicitly initialized my name to this value in memory. This has no initial value, and I'm sure that you have created code in C that had no initialization either.
What I think is happening though is that the C can be made safe, but you have to have the right. It's harder to make. It's not safe by default. You can make it safe, but it's more workarounds, stuff like this. You always have to have different things. You have to add a null bit at the end of any string, of any user requested string. It requires a lot more control, and it's not by default. So I think that's what's interesting about it. Is that it can be made safe, but it's much harder than it is on any other code.
Initialization, it will simply have the value that happened to be there on the stack left over by a previous function. You can try it. Create a program like this, run it, and see what it tells you. Actually, we'll also go through it in a future video more in depth. But it is a major issue facing C programs. So these are the four major problems: initialization, metadata, control data, and basically the ability of a developer to shoot themselves in the foot. Is it possible to write secure C code? Absolutely. It's not that C is an insecure language. C gives you the tools to use it in an insecure way if you so wanted to. That's kind of one takeaway I'd like you to take from this course. The other takeaway, or from this module, the other takeaway though is in many cases, it is very, 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 very easy to misuse C and other low-level languages in a way that ends up in the creation of insecure code. I'll see you in future videos of this module. We'll go in depth into a couple of...
It'd be nice to have a little bit of memory corruption. Okay, there's a few more videos, and then we're gonna do our first overflow. Easy, hard, precision, variable control, control hijacking. I think what folks will do one more video, smashing the stack, and then we'll do one more and then we'll do our first overflow. And this is the plan for today, for the rest of the stream. Oh.
Hello,
what a
hackers.
cutie.
Welcome to Pwn College. I'm Jan, and in this video we're going to be talking about memory errors, specifically a very simple type of memory error, kind of the classic stack overflow. We're going to talk about smashing the stack. Let's start with a simple example. This will be the example of the video. Let's say we have a program, and the program takes...
So folks, earlier Shoshi was the first part of his last name. We figured it out. That's why we had it in the slide.
Input from the user on the command line as a command line argument. That's right here, right? And it passes it into this print quoted function. And the print quoted function prints out a quoted version of the string. What does the quoted version of the string look like? We have this quote function that has an output buffer, and it uses sprintf to fill the output buffer with a version of the string that we passed in surrounded by quotes, right? This program has a number of bugs in it, and in this video we're going to talk about the stack overflow that's present in this program. And the stack overflow occurs in this sprintf. This sprintf is unsafe. It has no way of understanding how big the buffer is, and so there are problems.
Mm-hmm.
And of course, the user input is not limited. So let's see what happens.
Folks, how much of this code do you understand? Just realistically, how much of it makes sense to you? Init, argument, car, star star, argv, car, envp. Okay, there's definitely a function called print coded arg. I think it might have been defined by the user, or maybe not. Print coded argv. You understand none. There we go, Jim. This is pretty advanced stuff. Hey, good morning, Jim. Good to see you. None. Yeah, makes sense. I think it's pretty damn challenging. This thing. Main arg C, arg V. Let's see. Let's keep doing the plan. Let's keep following the plan, and then we'll see how we do, whether it makes sense to keep going.
When a malicious user passes in a very long argument into argv1, a very long string. What happens, of course, when sprintf runs, it allocates some space on the stack.
I'm going to turn on the heating. I'm a bit cold. Heating is on, folks.
Creates its metadata or whatever local data that it needs to have. And when it launches, there's this return address that is pushed. And the return address says, when you return from sprintf, go to this line 14 in the code. Of course,
Okay. So wait. Let's try to understand it here. This was important. Jim the Dandy, we're becoming master hackers together.
Launches, there's this return address that is pushed, and the return address.
So there's a return address that says go back to this one.
Says when you return from sprintf, go to this line 14 in the code. Of course, we're looking at source code. In reality, this will be binary. Then sprintf writes one quote, then the input, and then another quote onto the stack, onto specifically where this output buffer was. And the output buffer was in the stack frame of the quote function. And when the output buffer is filled, because there is no limit on the size of a command line argument, or I mean, there is, but it's like 65 kilobytes, the entire output buffer, which was only 16 bytes long, is completely filled up. And if you notice, when you pass in this output into sprintf, all that it takes is a character pointer. Let's take a look on the command line here. Man sprintf. Sprintf takes a character pointer for its output buffer. It has no way of knowing the size of that character of buffer, and so it has no choice, without any additional information provided to it. And of course, in a well-formed program, you could put a size limit here, for example, or you could use a more safe function such as snprintf. It has no choice but to copy the whole string. And of course, if the whole string is too long, it'll overflow. And what was over here? Over here used to be the return address from quote, which said when quote returns, go to line 9 or in the source code and print quote, or whatever binary instruction corresponded to that. So what happens is the attacker input overwrites everything, writes over the buffer, and writes over that return address. Then when that return address, when the return from the function happens, there are bad effects. So what went wrong here, right? Two things went wrong.
We're almost there, folks. We're gonna watch 12 more minutes of this, and then we'll try to do our first buffer overflow together, and hopefully get it right. Lazy and secure programming get string copy, scanf, printf, etc. Here's printf. Sprintf. Passing pointers around without their size, even if we want to see a safe function such as SN printf, there was not enough information.
Wrong. One is a kind of lazy programming practice. It's
Sup,
very
man?
easy to
Good, sick in the mind. We're doing some binary exploitation, and it's fun. It's just really complicated. Thank you, sick in the mind. You're pretty advanced in cyber. You might be able to explain these concepts here. So yeah, we're just finishing up this video. There's about 12 more seconds on. Unfortunately, I don't think you're allowed to do the solutions for this on stream. Ah, yeah? Oh, I never checked this. Yeah? No, that's not gonna be snitching, but that's part of their stuff. Not that I'm gonna be snitching, but it's gonna be part of their stuff. You think they're gonna be haters if I just do this first part? We're just gonna do this. I think they're gonna be okay with it. I don't know. Probably not. I don't know. But let's see what happens. Maybe they're gonna be hating and they're gonna sue me. Probably not the beginner stuff as much. Yeah, we're just gonna do some beginner stuff. We're not gonna go do the advanced stuff. We're gonna do this. We want to realize what it is, get the free knowledge, and then we'll go back to something like Pico CTF to do some real CTF afterwards. But here we're gonna get the free classes, which I think are YouTube, so that's fine. Get str copy scanf. So we're learning about this for 12 more minutes, which is memory errors, smashing the stack, which we barely understand, and we're going to do our first overflow. So this is what we're going to do. Stick in the mind. But thank you for your tip. I didn't think about looking up whether we could do that.
To sprintf and cause your stack to get overflowed and bad things to happen. But there's a more subtle problem. The more subtle problem is in this program, there were pointers being passed around to variable size data structures without the size also being passed around. If instead of a character array, instead of a character pointer of output being passed in alone with no size information, if instead the program used something like snprintf, let's take a look at our man page again. snprintf takes the character pointer, the character buffer pointer, and a size, right? If this was used and the size was passed in, this bug could have been avoided. Unfortunately, oftentimes in C, because there is no implicit metadata to anything, you see a lot of these sorts of memory errors leading to buffer overflows.
So what I see is that the way that the things are chosen, like printf is not secure, but there's other functions that are more secure. It's weird. If I were a company, if it were possible, maybe I'd try to ban printf being used and force other things to be used in my application development. Be an idea, but I don't know how feasible it is.
In real code. All right, so let's say, what can you do with this memory corruption, right? Let's ask this for ourselves. Well, you can do a lot of stuff, right? You could, of course, override memory.
That's a commonly used policy.
Anything.
Oh yeah.
There's plenty of memory padding on the stack.
And does that make
boring?
Does that make it safe now? If you do this, is it enough to make it safe? Probably not. No.
Right, but then there are a couple of more interesting things that you can do with a stack overflow. like we were discussing, right? You could overwrite some other memory on the stack, other local variables, for example, in that same function that are used to influence some mathematical operations, some conditional jumps, etc. Right? You might remember the win. Well, I guess you won't have seen that yet in the challenge problems for this module. You'll see these sort of very.
What is that? Second domain version MDS redirected from MSD. I have to type it up. Previous versions BB. Let me just look at it through my browser. Learn Microsoft previous version. Security functions development lifecycle banned functions. Wow, this is from 2021, 2011. This paper is derived from the book The Security Development Lifecycle. So in the link that Sick in the Mind shared, that's making the screen very bright from 2006. Yeah, is showing different functions and their safer alternatives. And they're recommending to ban certain functions and use different ones instead. Print? Is there a print? If you remember, folks, we did one of those not too long ago. So yeah, there's another one now called Sprint F_S. And do you agree, Stick in the Mind, that that this is not enough, no, to make C safe by nature, or is it? Just switching functions from one day to the next, doing Control F and reprogramming everything, doesn't necessarily make your functions. Doesn't fully make C. Is not the only problem with C.
Variables that you can overwrite and influence. You could also overwrite some memory that is used as a read.
Yeah. It's still very popular, I think. But yeah, I understand why it's not as popular. Look, low level control is something that's hard to replace, no? It's harder. What we saw in medical devices is that some people were recommending to use C only for when it's absolutely necessary, and then for the external facing parts, you want to use something a bit more robust, a bit more stable, that doesn't give as much access for the external connections. Something like Python that has a little bit more checks, a little bit more robust, but a little bit more slow.
Read pointer or an offset of a read pointer that'll allow you to force the program to access some memory that it wasn't supposed to. Right? You could do the same for a write pointer, allowing for what is called an arbitrary write, or a memory overwrite vulnerability. And you can use something similar but even more brutal, which is overwriting a code pointer, a pointer that the program will later use to transfer control flow. For example, the return address that we saw being overwritten in the example. This is called a control flow hijack exploit, and it's a very, very powerful type of exploit because you take control of the program. Typically, of course, you might be able to do multiples of these effects by either triggering the same bug multiple times or the over.
Oof, kind of boring. All right, let's try to do our first one. Let's try to do our first memory exploit. All right, so hopefully they don't. All right, start privilege, and then we gotta get the flag. Ooh. All right, let's start it. Submission failed. Unexpected character, line 4. Oh, we have to log in. Darn it. All right. Forgot your password. Log in. Register. All right, I'll be right back. Take a break. Overall chilled. There we go. Yay. Overdrive 1 subscribed yesterday, folks. So if you want to be the new, latest awesome follower, please follow. All right, username. I don't know why people are so. I have a good stream. Learning CL. Gotta catch some sleep for work tomorrow. Sounds good. Thank you for being with us. Sick in the mind. Good night. Take commitment. So they're very much. So I read the rules to register. They say I have read the ground rules and commits not to publish pawn.college write-ups on the internet. Why are you so against it? Because then it's not viable. Even master hackers have vulnerabilities in the software. If you find vulnerabilities in this platform, please email us rather than pawn us. We'll appreciate it, and you'll get extra credit if you're an ASU student or an awesome scoreboard award. You'll get extra credit. Wow, that's such an American thing. Extra credit or an awesome scoreboard award. Nice. All right, so let's submit. I think it's okay if we do the small one. All right, we in it. I'll show you in a second, folks. Let's just get back to where we were, which is reverse engineering. No. Program exploitation. No. Program security. Where the fuck is our thingy? Dojos. Is that the thing? Linux, start here. Over. Intro. I think it was under program security. Modules, reverse engineering, return originate programming. What the fuck was I doing? Ah. My lord, there's so many paths to do. They're funny. All right, I'm going to share with you the screen. Scene. There we go. We're back. Where do we go here? Your dojos, challenge the world. Where the fudge are we? Start here. No, we're not at the start here thingy. Probably not. Join the Discord using the dojo. What is Pawn College? What is cybersecurity? Absence. Proving absences of cybersecurity. Proving the insecurity of hacking team. Cybersecurity ethics. All right, so where do we go here? Programs, cyber system security, is that it? Sandboxing introduction. Where the fuck is it? Ah. Let's start here. Pawn College. Oh, I think it was here. I remember binary exploitation. There we go. Intro to cybersecurity. Binary exploitation. Okay, here we go. We're in it. First overflow. Let's do this. Start. Nice. It looks good. Challenge successfully started. Oh, what a nice one. All right. LS. Hacker. Okay. What do we do here? All right. We've config. Oh, I have no idea where to go. And what do we do if there's no? What do we do if there's no? If there is no. Damn it! If there is no. Where do we start from here? Overflow easy. Okay, so there's probably something. There's no write up. That's the thing. Write ups are the best things. They're the best way to learn when you don't have a teacher. Because you don't have a solution sheet, no? Pi is easy. String length easy. Shellcode injection introduction. Oh lord. I think it's really too bad they don't allow it. I don't really like this method of teaching of just, oh yeah, let's make our space really, nah. We're all here to learn. We don't have to make everything competitive. I agree, there should be a space for competitiveness, but this is not it, right? We can all be competitive. It's one of the most advanced arts in cybersecurity. I'm gonna learn so much better than you. Why? Grey Hatter, hello. Good to meet you. I don't think we've met before, have we? Grey Hatter. You're going up just slightly slower than me. Ho ho ho. Nice, Grey Hatter. Great, great. How can you tell that you're going faster than me? Tell me, show me your arguments. Give me your arguments. No, Grey Hatter, we've met before. I'm lying. I remember you now. I remember you. So what would you do here, Grey Hatter, if you're so much better than me? Well, if you're faster than me. .config. I was just making a joke about learning being competition. Ah, okay. Good one. Ha, being faster learner. It's a good one. But hey, for real though, Grey Hatter, do you have an idea what we should do here? Kind of lost. We should do a buffer overflow, but there's. I mean, if it's easy, there should be a program to overflow. CD. Boom. LS. Nice. So we can go into our home now. CD. Home. And then PWD. Home hacker. What's the conf dig? Yeah, okay. Let's go. cd.config. Hacker dot and dot cat bash history. Then probably reset the box. You think so? Where's the batch history? Bash that history. Oh, it's right there. It's be hello. cd dot cat dot bash underscore history. Bash bosh. That's with an S. Bash history. Okay, so we can see what we've done. I'm not seeing any clues. Yeah, I think it's too advanced. Lol, completely nothing. We're redirecting. We're resetting. But there's nothing. I don't think it's an us problem. I don't think it's a name problem. LSLA config. Folks, bit exploitation is too advanced for us. Yeah, I'm out of ideas without more context. How long ago did you just arrive? Did you just arrive? We're doing memory exploitation, binary exploitation, because the story why we did this is because we did a Pico CTF challenge. Was it on Monday to finish the stream? And it was about binary exploitation, and we're like, oh, this is easy. Why don't we get it? And it was called Pi Time, and pi is a reference to binary exploitation. Don't ask me why, but there's a whole binary section, binary exploitation section, and it should be easy. So it should be easy for us to do. But the thing is, we have no idea how it works really. We don't really know. Sorry, know if I. Yes. Font College now. Yeah, I didn't know about this platform. It's pretty good. But not super easy. 9,000 solves. But we have no NoidPy. Maybe you can tell us how what would you do here? We did LSLA and we don't find anything here. What would you do to do a buffer overflow? The hacker is back. Hey Slotchy. Yes, we're here. Slotchy is on YouTube, folks. Maybe I should adjust my stream so we can have both YouTube and Twitch, but I think Twitch doesn't allow for that. We'll figure it out. Hey Slotchy, good to see you. Look, Slotchy, if you're good at hacking, can you help us? I'm trying to beg help from anyone coming into the chat. Can you help us understand this? Hacker, like, what would you do here? We're supposed to do a buffer overflow. Bash config. Where do you do a buffer overflow here if there's no C programs? Click on the terminal button. What do you want to do? Lock it? On the terminal button. You want to make it bigger? There's nothing overflowable there. Yeah, not really. I try to poke around, but I'm not creating an account. Nah. Click on the terminal button. Left. Yeah. Code. Desktop. SSH. So we could SSH into that. Your SSH key. Okay. Code. Okay. Doesn't allow us to code. Desktop. I mean, we could have desktop. It won't change too much. Pawn.college. All right, desktop. Probably let's just do terminal. It's probably the easiest. It says terminal. Is that what you wanted to explore? Hacker, binary exploitation, your first overflow, easy. Folks, as if this is easy mode, what the fuck are we doing? Easy. All right, so what do we do here? LSLA, we didn't find anything. Echo path. I'm actually going to type just that, huh? Echo $, path. There's a lot more things in there now. Oh, you're right. ICE authority, cache, config, dbus. What the fuck happened? Ah, maybe because I needed to create something to get the desktop and all. LS run dojo bin. Damn, Grey Hatter is helping us big time. Run challenge bin. Ooh, great stuff. ls la star dot star. I think we can just do la star. Hacker this. Oh, wow. Wait, what? There's a space. Oh, okay, okay. Yeah, I've never seen this. LA star, that's star, but I wanted to recurse to theirs too. LA space LS LA space star space dot star. Ooh, what does this do? It's interesting. You want to see all? The end in all? Oh, that are hidden. Oh, you want to see all that are hidden, I guess, no? This is what it does. Microsoft dconf. By default, if it starts with .a, won't find them. Yeah, exactly. Okay, okay. Nice. Agent, bus, okay. Microsoft dconf f fonts config session. Is there anything hackable here? I think your bin is run challenge bin. Yeah. Run challenge bin. Oh, we did buy, but I think it should be bin. How did you know about this place? What does Echo Path do? What does this do? Grey Hatter. Echo Path. And I know you were kidding earlier, but yeah, I think you're learning faster than me. So you're in a bash shell right now, right? Yes, we are. What does this do in bash? Type which bash. All right, let's do it. Let's do it. Run dojo bin bash. Ooh, I think I understand this command. It's because there's different bashes, which is a shell command. It asks for your shell where that file lives. Nice. So that's the full directory. Uh-huh. So path asks where the thing lives. Path is a colon separated list of directories where bash looks for executable programs when you type a command. User local bin, user bin, user bin, sbin, home user bin. That what that means. When you type a command like Python, bash searches in this order: user local bin, user bin, user sbin. Okay, nice. Oh, I see. Well, that's really good insights. Thank you for showing that to us, Grey Hatter. So that's a full directory. But you don't have to type the whole directory. You can just type bash until it runs. The path var is everywhere your shell look for the programs you run. Yeah, nice. Woof. All right, can we do path Python? $ path. I just reprinted Python. Try lsla user bin to see if there's another version of bash in there. is bash. Max count. Right error. Broken pipe. I grew up instead of grep. Oh, yeah, that's good. Grip is not the fine recommend. That's a fine argument. All right. It's not happy. GURP. Yeah, I don't need name. You're right. Name is for find. Oh, there's none. Let's say bash in there. That doesn't work for that. Like that. Find doesn't work like that. No. Ah, Grey Hatter. You must be losing your mind. I haven't been on Discord in a little bit, actually. Maybe I should see something. Do you want to go on Discord? And we can talk about it. Grey Hatter. Single quotes means little this. Literal star. Do 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 do. Do 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 do. People were chatting 2 days ago. Ooh. Could someone call? Guess you're having fun on the Discord. Just bash. Sorry, just feeling antisocial. That's all good. So no single
So
quotes.
Ankit is asking one question.
God, I'm letting other people run the Discord. I'm not doing too much there. Are you sure my project copilot? Alright. But you're a little late. Okay. Woof. Alright, just bash. Alright, sorry, I'm a little feeling antisocial. That's okay. I understand. Alright, let's go. LS. Don't work it like that. No single quotes mean literal. Sorry, I'm feeling antisocial. Just bash. Okay, let's just bash. Okay. GURP bash. Oh, yeah, that's much better. Alright. GURP bash. We have bash bug. Env bash. R bash bash. In parallel bash. Bash. R bash. What do we do from here, Grey Hatter? Sorry, folks, just planning on my day. Oh, so much going on. So there's two versions of bash. The one that lives at run dojo bin bash is the first in the path. I would lsla run challenge bin again to see if there's a binary, or if it's a full directory, and see what's in there. Otherwise, I'd run that binary command, see what it does, and then open it with radio. Dude, Alright, let's follow Grey Hatter's instincts, but I think we need to stay on more beginner stuff a bit still. I think we've been humbled a bit lately. I would lsla run challenge bin again to see if it's a binary or if it's a full directory, and see what's in there. lsla run challenge, okay. Well, let's go into it. cd run challenge Can't type today. Challenge bin. Huh? That's weird. Yeah, where did it get run? I didn't put a dot. Should I have put a dot to make a run? Scroll up a bit. QRS run. It's quite a lot to scroll here. Root, so much new stuff. Alright, you see it's taking all the space. I'm looking for first ls command. Because it did exist, right? I'm not crazy. Gray hat, I don't know how to put this. Gray hatter, you might be crazy. Challenge bin. Echo path. Run challenge bin. Yeah. Run challenge bin. I think it's in there. Yeah, we can go. But I think we were in run dojo bin, huh? That's so weird. I think this one doesn't work, actually. It's the first location it checks, but there's none in there. So I think it's run dojo bin. Ah, there we can be. Uh-huh. The fuck is that? YP domain. Nix. Store. YP domain. So weird, I agree. What the fuck, folks? I think we've been humbled by this. It's only been 106 days. We're still beginners. I see this very first letter is L. That means it's a symbolic link. Ay, fudge. Fudge. Folks, I need to get to work kind of soon. Buffer overflow is not a good idea. It's just too hard right now. Hopefully I didn't disappoint you. Hopefully. I mean, I understand if you'd be a little bit disappointed. You're like, wow, he's doing bit exploitation. He's really a genius. And you're like, nah. Which is just the Nix OS magic. Yeah, we definitely know what that is, Grey Hatter, of course. Nix OS magic, yeah, it's like... it just makes perfect sense. I was going to try to find a joke, but man, my humor is pretty low today. Man, I need to stop hating myself. Hating on myself. I'm not hating myself, but hating on myself. All right, folks. I want to start a book club. I don't know. XR's idea of once a month reading a book sounds really fun. And he gave us a good one to start with. Maybe we can do this one. Maybe we can do this one. Which book are we going to do? I might be talking about it alone, but at the beginning. But it's okay. We're going to do Hacking, the Art of Exploitation, 2nd edition. So, Hacking the Art of Exploitation. So we might start with this one. I'll do a publication. To be fair, I also don't know the Nix magic. Nix has a lot of that kind of magic. Ooh, it's a kind of magic. It's a kind of magic. All right. Folks, today we got humbled. And tomorrow we come back stronger. And how do we come back stronger tomorrow? Tomorrow we'll come back stronger and we can... What are we going to do with that? We're going to come back stronger, and we're going to get some, and this will ultimately become revenge. Sometime in the future, we'll get revenge. Folks, this is something we do. When we're not good enough at something, we come back and we get revenge. And tomorrow we can do some hack the box, try hack me, stuff like that. Yeah. I think we'll try to do some try to hack me tomorrow. Try hack me. Let's see what we can do. And maybe I'll order the book. Sounds pretty good. We're going to get a nice library of hacking stuff. Hey, you're cyber doctor. Admin password. Oh. We've made changes to improve your connection. We switched to Europe Frankfurt. Okay. Don't care too much. And then tomorrow we'll look for something. We can do a little box, a little challenge, reinforce your skills. We're going to do difficulty. We're going to do easy, medium. I'm going to stick to easy this time. We need to gain some confidence. Red. A classic battle for the ages. 180 minutes. 3 hours on one box, folks. To find 3 flags. You are blue, and you can only take red down. However, red has implemented some defense mechanisms that will make the battle a bit difficult. Red has been known to trick adversaries out the machine. Is there a way around it? Red likes to challenge adversaries' passwords, but tends to keep them relatively same. Tends to keep them relatively the same. Red likes to taunt adversaries in order to throw their focus. Keep your mind sharp. This is a unique battle. If you feel up to the challenge, then by all means go for it. Whenever you're already clicking the start machine to fire up the virtual machine. This one looks fun, but 3 hours. There's write-ups? Wow, these guys advertise their write-ups. They're very different from the rest. So most people seem to get everything. This guy has a lot of points for some reason. King of the Hill. Cool, folks. This is it for today. We might start a book club, Hacking the Exploitation 2nd edition. Yeah, folks, that's it for today. I'll see you tomorrow in 22 hours. We've had Grey Hatter helping us out tremendously. We had XR at the beginning. We also had Bedro Dev coming into the stream. That was lovely. We had Sick in the Mind telling us that to give us some advice on how to stream this. And of course, we had Cyber Noipai and Slotchy were here too, just saying hello. So cool, everyone. Thank you for being here. Oh, we also had one more person. We had one more person. That was AI Roy. Yes, we had everyone. So thank you so much, everyone, for coming, even to just to say hi. It's lovely seeing your beautiful names in the chat. And folks, I'll see you tomorrow in 22 hours, 6 a.m. Paris time, midnight New York time. And yes, that's it, folks. I'll see you tomorrow. Ciao, everyone. Take care.